Hello everyone, welcome back to this session. Today we are going to discuss about how to overcome high-speed memory challenges in the early design phase. This is the part 2 of the video series on Keysight ADS Memory Designer. In today's session, we are going to perform pre-layout signal integrity analysis on LPDDR5 low power double data rate memory version 5 interface using Keysight ADS Memory Designer simulation software. Let's get started. For this simulation demonstration, I am going to use ADS 2025 Update 1. In today's demonstration, I am going to show you the pre-layout exploration, that is for the read as well as write cycle when it comes to LPDDR5. First of all, we are going to perform the LPDDR pre-layout read cycle. Double click on the schematic and open the schematic for this. As you can see in this schematic, there are total 6 components that are being added. When it comes to the read cycle, your memory will be acting as a transmitter and your controller will be acting as a receiver. In my example, memory is U60 and U1 is considered as my DDR memory controller. All these 6 components we are going to discuss in detail. Now, where did you find this? So all you need to do is just on the left side, you'll find this palette. Inside this palette, click next to this arrow near to lumped components and go down and search for Simulation Memory Designer. Now, once you click on Simulation Memory Designer, you will find all the components that are available with respect to pre-layout as well as post-layout. So the first component, that is the Memory Designer setup. Memory Designer setups gives you the idea and it gives you the leverage to select which particular interface you want to simulate, whether it's a DDR interface, graphics DDR interface, LPDDR interface, HBM1, HBM2, whichever the interface you want to run a simulation on, you can select it over there according to their speed grades as well as the different parameters to it. Then comes the DDR simulator, that is the memory simulator. DDR simulator will help your tool or your engine to understand which type of simulation you want to do. Whether you want to perform by bit simulation or you want to perform some sort of statistical simulation. Then comes your controller and your memory. As you can see in my example, I have added one controller, that is U1, and one memory, that is U60. And then comes the PCB. PCB, this particular component is used whenever you are performing a post layout simulation. But in this condition, in this particular example, we are performing a memory pre-layout analysis. So for that, we need to select the second part. This one is used for DDR pre-layout analysis, where it contains all the data of your traces as well as your vias. And if you want to add some sort of memory transmission lines or a bus transmission, then you can use this particular part. Now, this is all that you require, and there is one more important part where you want to probe. Okay, so for that, you need to, and your tool need to understand where exactly the probe points will be. So for that, we have something known as memory probe. You can find the memory probe from this palette itself, and you can put it over there. This is the one from the palette, that is the memory probe. Now let us deep dive into all these other parts. So first of all, let us discuss about the memory pre-layout. If you want to perform the pre-layout analysis on your traces, there is a Keysight ADS tool named as CILD. CILD stands for Controlled Impedance Line Designer, that can help you to understand and to decide on the layout guidelines that you are going to put with respect to your traces for your layout engineer. And then if you want to work upon your vias, so for that there is a tool for with Keysight ADS known as via designer. Keysight ADS via designer. Inside that via designer, you can put all the values and you can perform a pre-layout exploration when it comes to all type of interfaces, whether in DDR or serial link or in parallel link analysis. This data, what you are going to see inside this memory pre-layout part, is the data that we have got from CILD as well as the VIA designer. Now, first of all, double click on it, and then you're going to see the associated schematic. Click on the open cell, and here you will find the details about the substrate that has been used as well as your VIA as well as the trace EM models. As I mentioned earlier, if you want to perform pre-layout extraction for the traces, then you will use Keysight ADS CILD, that is Controlled Impedance Line Designer. And if you want to perform some sort of pre-layout exploration on your VRs, then there is a tool named as Keysight ADS VR Designer. Now let's just close this pre-layout part. Then comes the controller. Controller, in this particular read example, controller is going to act as your receiver. So there are two ways to put the values for the controller. For example, if you're having your IBIS file available with you, so you can directly import that IBIS file into this controller. And in some cases, if you don't have your IBIS file available with you and you are just performing some sort of pre-layout exploration, in that case, all you can do is just click on controller, add a new controller, double click on it, and you can select an option which is given over there without IBIS, EBD or EMD file. So this will give you the leverage where the internally available IBIS models will be interacted with your design and you can run your pre-layout exploration. So you don't have to be waiting for your IBIS models from your vendor. You can directly start with your simulation with this. Now, in my particular case, I do have my IBIS model attached to it. So double click on it. This is the IBIS model that has been attached with my LPDDR. This is for the controller part. All you need to do is just go to the browse and browse the particular file that you are going to work upon. Okay, import that, and here the first and foremost thing that you need to do is you need to assign the reference designator. So this IBIS file contains all the details, and this particular part has been taken from your pre-layout exploration part. So U1, so in my particular case, controller is the U1 IC. So just double click here and click on Y. So it has become yes. So the particular IC that is working as my controller is my U1. Then click on OK, apply. Then comes the memory. In the read cycle, memory acts as a transmitter. Let us just open the memory and check. So in memory case also, it is the same. If you're having your IBIS model attached with you and available with you, so in that case, you can definitely import your IBIS model by clicking on browse, and you can add your IBIS model to it. And if you don't have your IBIS model, then all you need to do is just click on memory, select a memory part, double click and select without IBIS EBD file. Click on next, and then you can directly select what kind of IC it is. So this is how you can perform without even having your IBIS model with it. But in this example, I already have my IBIS model available with me. So double click, and here also you need to mention which particular IC it is. So in this particular example, my memory is U60. So I'll just double click here and select Y, and then click on apply and click on OK. Now I'm done with all the three major parts of it. First is the memory pre-layout, then comes the DDR controller, and then comes the memory. I was mentioning about something known as smart bus wiring. Let me give you the demonstration of it. So smart bus wiring is something where it reduces the human effort as well as human errors for it. Now all you need to do is just in between them there is this symbol known as insert wire. Click on insert wire, connect both controller with your memory pre-layout. Now this particular palette is going to open where it will ask you to connect the HSD smart components. On the left side I have my U1 and on the right side I have my pre-layout. All these pins are being mentioned over there. Automatically it is being fetched, as well as all the reference designator also being added. Now all you need to do is just click on connect all, apply, OK. That's it. You don't have to worry anything about how the connections are being made. Then similarly, you need to connect the wire between your pre-layout memory component to your main memory component. So on the left side, we have DDR pre-layout one, and on the right side, we have something that is U60. Select both of them, click on connect all, apply, OK. So this is all what was required when it comes to connection, and that is the reason Keysight ADS has been majorly used, where it provides you smart wiring where you don't have to connect each and every DQ signals manually. You don't need to connect. All you need to do is Just connect both the controller and the memory prelayout and memory player prelayout and the memory component, all of them together, and the tool will take care of all these connections for you. Now let us discuss about the other parts of the simulation setup. So the first that I would like to discuss is the memory designer setup. Double click on the memory designer setup. As in the theoretical part, I was mentioning about Keysight ADS memory designer that can help you to provide to perform some sort of simulations, some sort of signal integrity simulations based on DDRs, graphics DDRs, LPDDRs, as well as on the HBM based designs. So as you can see over here, all these type of memories can be simulated on by using Keysight ADS memory designer. So the one that I am going to perform right now will be on LPDDR5, and the speed grade I need to choose. So the speed grade that I am going to use is 4800 Mbps, and which particular cycle you want to perform the simulation with. So currently I am going to perform a read cycle. That means my signal is going to travel from my memory to my memory controller. The memory controller is reading the data from my memory, from the particular memory. Now, for example, if you're not performing this kind of simulation and you want to explore more into different type of speed grades, so all you can do is just click on this option where you can select us and put up the value for custom speed grade. Whatever the speed grade you want to run the simulation in, you can use it over there. But in this particular example, I am going to go with the one which is available here. Then the next comes the DDR simulator. So DDR simulator gives the simulator an idea about which kind of simulation you want to perform. So choose the analysis mode. In this mode, if you want to perform a bit by bit simulation, then it will ask you about the number of bits that you want to analyze. And if you are performing some statistical analysis, then it will not ask you about the number of bits. So in my example, I'm going to perform a bit by bit simulation, and and then comes the BER. BER stands for bit error rate. So if you want, you can enable the ultra low bit error rate. That will be e to the power minus 16. Up to that level, you can put up the bit error rate for this particular simulation. So the last simulation setup part that I want to discuss is the memory probe. Double click on the memory probe, click on the select signals. This is where you are going to select the probe where you want to probe your signal. So in my case, U60 is my transmitter and U1 is my receiver. So I am going to probe at the beginning of U60 for DQ0 to DQ7, and then I am going to check at the receiver end, that is my U1. At the U1, I am going to set it as mother receiver part. Then once your signal has been selected, then click on this select measurements. Now, after the signal is selected, you need to select what kind of measurement you want to perform. Whether you want to see only the eye diagram density, or whether you want to see the other parameters of it, like eye height, eye width, eye level information, skew, slew rate, waveform, as well as eye height and width at the bit error rate. Or if you want to add any of these, all you need to do is just double click and click on add. If you want to add them to your simulation, then just click on that particular part and click on add, and then click on finish. After you have selected the signal as well as your measurement, just click on finish and add it. Now, as per the understanding, each and every part, there were six major parts when it comes to pre-layout analysis, pre-layout end-to-end channel analysis, and all the six we have taken care. Now let us just start the simulation. You need to click on this screw button over here. Just click and click on simulate. As you can see, I have just now clicked on simulate and my simulator is running in the background. And now once this simulation is finished, in my particular machine, it is going to take somewhere around 12 to 15 minutes to finish the simulation. I have already simulated these results where you are going to find those results. Now close it, click on no, and here you will find this result, DSS demo LPDDR5 pre-layout read. DDS. .dds is the data display extension. Double click on it, and here you'll be able to see my signals as well as the eye diagrams from U60 to U1, where it is the read cycle. As you can see, The eye is wide open at U1, and at U60 we were seeing some sort of crosstalks because of these bumps, and eye diagram looks pretty good. So this was all about the read cycle simulation, where my memory was considered to be my transmitter and my controller is considered to be my receiver. So this is how you perform end-to-end channel simulation with respect to pre-layout analysis. Now let us see the write cycle then. Close the close the schematic for your read cycle. Now open the schematic for your write cycle. Double click on the schematic. As you can see, all these six components remain same. What exactly is the difference? Let me just give you the difference. First is you need to connect, make the connections. Click on this wire, make the connection between your controller and your memory prelayout, and then connection between your memory prelayout to your memory. Connect all, apply, OK. Now, when it comes to write cycle, your data is getting written into your memory. So your controller will act as a transmitter and your memory will act as a receiver in this case. So all you need to do is just go to the memory designer setup, select the kind of memory you want to simulate, the speed grid to it, and instead of that read cycle, just make it as a write cycle. That is what the only change between this as well as the read and write cycle. Then click on OK. And once this is done, all you need to do is just hit on this simulate button and the simulation will get ready. So in this particular machine of mine, I'm using a 32 GB machine that has taken somewhere around 12 to 15 minutes for this simulation to finish. Let me show you the results for that first. So this is what the results for the pre-layout write cycle. When I say write cycle, so the strobed eye that you are going to see at U1 is this on the left side, and at U60 you are going to see this kind of eye. So with this, I would like to conclude the second part of this video tutorial series on Keysight ADS Memory Designer. I hope this session was useful for you, and in this session we have discussed about how we usually perform the pre-layout analysis when it comes to Keysight ADS tool. In the next video, I'm going to discuss about the post-layout LPDDR5 post-layout simulation, where instead of a pre-layout file, you're going to put the S parameter extraction file, and then you're going to run the simulation and check end-to-end channel for it. Stay tuned for the next video. So I would like to thank you all for joining this session. In this session, we have seen the pre-layout exploration for LPDDR5 simulations. In the next part 3 of this video tutorial series, we are going to see the post layout analysis for LPDDR5, and in that we are going to use the S parameter extraction, and then end-to-end channel simulation is what we are going to do. Stay tuned for the next video. If you have any doubts, comment down below. Thank you. Have a nice day.